Alright, grade 11s, welcome to your second trigonometry lesson. Please get your calculators out. We're going to work together on this. I have posted these slides on the Google Classroom, but please make sure, I hope you are watching this video before you try attempt the slides, because it is essential that you listen to my teaching before you try and get into it. So get your calculators out with me and just have them on degrees, and then please type in sine 60. So once you type sine 60 into your calculators, you get root 3 over 2. Now I want you to type in cos 30, and it's also root 3 over 2. Then type in sine 50, 0,766, cos 40 is also 0,766. Sine 15 in decimals 0,259. Cos 75 is also 0,259. This is getting very interesting. Cos 110 is negative 0,34. And negative sine of 20 is also negative 0,34. So let's try and figure out what on earth is going on here. So if I were to show you something here, what is common amongst all of these? All right, so do you agree it's 60 plus 30 will give me 90? So we can drag that across, 90. 50 plus 40 gives me 90. That will give me 90. But then these ones, if I were to subtract 110 minus 20, I'm going to get 90 degrees. And also there's something weird going on with that negative coming in there. But we're going to look at these now as rules, as formulas on the next slide. All right, so we are looking at something called a co-ratio. Now, co stands for complementary. Ratios referring to the trig ratios of sine and cos. Now, it's not saying to us that they're being nice to each other, complementary, they're complementing each other. No, in maths it means adds up to 90 degrees. So these are complementary ratios, meaning that between sine and cos, when they add up to 90 degrees, they are equivalent to each other. So if you had sine of 1 degree, cos of 89 will give you the same answer in your calculator. Cos of 20 degrees, sine of 70 degrees, for example. So the easiest ones to work with and the most common ones to work with are the 90 minus. So I could say to myself, I have sine of 1 degree. That is the same as sine of 90 minus 89. Okay, so 1 degree and 90 minus 89 is the same. But then because of this bracket, I've got 90 minus with a sign, I can change that to cos of 89. So I can make that cos of 89 degrees, which comes from there. All right, so same thing with cos. If I had let's say, cos of 60 degrees, then I know I can rewrite that as cos 90 minus 30. That's equivalent. 60 is the same as 90 minus 30. But when I see a cos with a 90 minus in it, I can make it sine of the angle that's in the bracket. So cos of 60 is the same as sine of 30. 60 and 30 make 90. But then the problem comes in with the cos of 90 plus. All right, and all of this has to do with graphs, which we're going to come on to the functions and shifting of graphs. So I don't want you to think too much of why this is happening. Just accept that it is a rule for now. When we get onto the trig functions, we'll show you the shifts left and right of the graphs and how they change into each other. All right, so when we're working with the 90 plus, all right, so I'm just going to move it here. So the cos of, let's say, 110 is the same as saying cos of 90 plus 20. Now that is how we got on the previous slide a negative sign of 20. All right, so you replicate 110 in a bracket in an additional subtraction form, in this case 90 plus 20, and then you replicate the rule from the bracket above, that 90 plus can change to the negative sign of the angle within the bracket. But it only happens with cos 90 plus. If you had sine 90 plus, so let's say sine of 110, it's the same as saying sine 90 plus 20, which will just be cos of 20, not negative, but positive. All right, again, we'll come back to it in the function. So for now, you can just learn it as a rule that the only one that's a problem here is the cos 90 plus. But in all honesty, you shouldn't really have to use these co-ratios too much, because what I like to do is when I have something that is bigger than 90, an obtuse angle, cos of 110 degrees, I would rather use my cost diagram. 110 sits between 90 and 180, and so it's 180 minus something is going to get me to negative cos, because we're in sine's quadrant, of 180 minus 70 degrees. And then you have already got the same as, so negative cos 70, which then you can replicate as negative sine 20, because then 70 and 20 make 90. And if you have a look here, that would be the same thing. All right, so I prefer to use proper reductions, taking obtuse angles and making them acute, rather than messing around with the 90 plus co-ratio. But it's up to you. Again, we are going to practice a whole lot more, especially when we get back together in class. All right, the next thing is called a negative angle. So normally we rotate anti-clockwise, positive angles. So theta, 180 minus theta, 180 plus theta, 360 minus theta. But when it comes to negative angles are things we don't like working with. It's actually going the opposite way. But I don't want you to focus on anything beyond that first one here. So a negative angle, regardless of if it's 0 to 90, 90 to 180, you can treat it as if it is in quadrant 4. So only cos will be positive, sine will be negative, tan will also be negative. So if I get your focus up here, sine of a negative angle becomes negative sine of that angle. You take it as if it's in cos's quadrant, so sine is negative. Cos of a negative angle, though, you pretend it's in cos's quadrant, it goes to positive. And then tan of a negative angle, tan would be negative in cos's quadrant. Okay, we're going to work with a couple of examples on the next slide. All right, so now, just to make a little side note here, it says for angles bigger than 360, subtract 360 as many times as you need until you get an angle smaller than 360. All right, that's because our cost diagram works from 0, 90, 180, 270, 360. So we want to try and get on our cost diagram. All right, so our main aim here is to use the rules that we've now learned. So let's see, it says without a calculator, which means use your rules and use special angles. Okay, sine of negative 30. Now we've just learned that sine of a negative angle, we pretend we're in cos's quadrant, so it would be negative sine of that angle. So that's going to become negative sine 30 degrees. And then your sine of 30 degrees is a special angle of a half. So that's going to be negative a half. Right, so that whole thing gets replaced. Then for the next one, you first deal with the negative. So first deal with negative, then reduce using the rules that I've taught you. So cos of a negative angle, we pretend we're in cos's quadrant, so we take its positive version. Then, so that was dealing with the negative first. Now we're going to have to reduce. So you go to your cost diagram, 0, 90, 180, 270, 360, and you ask yourself, where is 240? 240 is in tan's quadrant. So cos is going to be negative, and we've got to ask ourselves 180 plus what would get me 240? It would be 60 degrees. Now we've just learned that sine of 30 cos of 60 will actually give us the same answer because of the fact that we have a 30 plus 60 is a 90 relationship. But if you don't believe me, type in your calculator cos of 60 and you end up getting a half. Don't forget your negative from the reduction, and that is a half. All right. Then for tan negative 390, again, always deal with the negative first. So tan of a negative angle, we pretend we're in cos's quadrant. So we get negative tan of that angle. Now we've got a number that is bigger than 360. So we're first going to take off 360. So 390 minus 360 is equal to 30 degrees. And now it's already reduced, because 390 is not on my cast diagram because it finishes at 360. We can't go more. So we just chop off 360 to bring it onto the cast, and now it actually sits in the first quadrant. So we'll leave tan as is, and in your calculators or with your brains, you can work out the special angle of tan 30 is root 3 over 3. All right. And or 1 over root 3 if you're using the other method of special angles. Okay. All right, grade 11 is the last slide for this video, and then I will show you just some exercises and pages you can look in your Mind Action Series textbook. Again, just a reminder that any angles that are bigger than 360 or not on your cast diagram, that's just a big thing. So if it's not on the cast diagram, from 0 all the way around to 360, work with 360. So I'm going to show you what I mean by that now. So for this first one, sine of 360 plus theta. That's bigger than 360. It's 360 plus. We're adding on to it. So let's subtract 360 here. And what will we be left with? 360 minus 360 is 0. So we're just left with sine theta. So here, for sine 360, so sine 360 plus theta. If we chop off 360, we just left with sine of 0 plus theta is theta, and that would be your final answer. We're just trying to break it down. For number 2, cos of 540 plus beta. 540 is bigger than 360, so we need to subtract 360 off of that. So 540 minus 360 is equal to 180 plus beta. Now you need to recognize that we have reduction formulas, reduction equations here, like rules, and this one now matches the one that is in tan's quadrant. So because it's in tan's quadrant, enemy territory, cos is going to be negative. We are aiming to reduce. So reduction means we are getting rid of the big piece of the angle. So when you're on 0 to 360 in your cast diagram, you're just going to lose that bigger part and apply the correct rule for the correct quadrant, positive or negative for cos. All right, for number 3, tan of theta minus 180. So now, I know we said if you've got a greater than 360, you subtract off, but now we're on a negative angle. So I prefer then here to get onto our cast diagram, let's add 360. So this is going to become tan theta. If I add 360, it's going to be positive 180. And I can rearrange that to become 180 plus theta. I'm not doing a switch around. I'm not taking out a negative. Both are positive here, so I'm literally just rearranging them. And that is now in tan's quadrant, which means tan is positive. We drop the bigger angle. All right, we get rid of the bigger part of the angle. We're reducing it. So tan of 180 plus, so bigger than 180, is the same as tan of that angle, smaller acute angle. All right, there is an alternative to this, and that is to work with a negative angle. So you could take out a negative and do a switch around here within this. So then you would treat this as a negative angle with tan like we've just covered. So it would become negative tan of that angle, because we pretend we're in cos's quadrant for negative angles, and then we realize that 180 minus is in sine's quadrant, so we get a double negative here, and a double negative gets us a positive, which is the same. So I prefer just to add 360. It's quicker, but it's up to you. You can work with the negative angle. Then for number 4, sine of negative theta minus 90 degrees, right? And again, because I've got negative, don't worry about this theta piece. Worry about the number. Because I'm on negative 90, I can add 360 degrees to that. But then it gives me something that is a bit problematic. So sine of negative theta plus 270. Right? So sine of 270 minus theta. I'm just rearranging it. Now this is another co-ratio type, but we don't teach it in school. So don't do it. Some of your tutors might work with it, which is fine, and your textbook works with it, but we don't teach it because it just complicates life. So when you get ones like this with 270 minus theta, you need to stop, and they are forcing you to go back and work with taking out a negative angle. So as soon as you hit that 270, things must like flash in your brain and go back, and they're forcing you to take out a negative. Right, and then you can do the switch around with it. So 90 plus theta, and then you end up with sine of a negative angle is negative sine of that angle. And so sine of 90 plus is cos of that angle. All right, so you have the option, if you really do want to, you can learn the 270 co-ratio from your textbook or from your tutors. But for now, we are working on just sticking with the 90 co-ratio. So the sine and cos with 90. So when you get ones where you end up with 270, try work your way backwards and keep the 90 plus relationship. Again, it's completely up to you, but I'm not going to be teaching the 270 co-ratio. And I know most of the other teachers won't either. All right, the last question is simplify cos 920. Cos 920 is much bigger than 360, so you can take off 360, but then you get 560. So cos of 560. So then you'd have to take off another 360, which gets you to cos 200. You can go straight to that to cos 200. Then on your cos diagram, because 200 is bigger than 90, but it fits between 0 and 360 degrees. So you got to look at your cos diagram, and you need to ask yourself, where does 200 fit? It fits in tan's quadrant. So 180 plus something gets me 200. That something must be 20. You keep the same ratio, but because it's in tan's quadrant, we have a negative in front of it. And that's how we simplify it. All right, grade 11s. I've just listed here, and I will post this in a Word document a bit later tonight, just some things you can look at in your textbook on this. So we've pretty much finished probably about 80% of the new ideas for trig. We're just going to mix them together, and then we have one new idea with equations, and then the trig function. So there's not too much to do with the new trig, but it's just about practicing. So in your Mind Action Series textbooks, your school textbooks, from page 106 to 108, there is information and extra examples on reductions, and exercise 2, try them all. Right. Then for page 109 to page 110, it talks about negative angles and angles bigger than 360. And then page 111 has some more examples as well. Then on page 111, there's exercise 3. Please try the questions here, A, C, E, G, I, K, and M. Try more if you want, but do those ones. And then page 112, it talks about co-ratios. They're also called co-functions. And then 113, I've said, please don't worry about the 270 degree co-ratio. If you really want to, you are welcome to study it and go through it, but it's not compulsory. We're not going to do it in class. Page 114, there's a couple of extra examples. They work through them, they explain everything, they go through each step, so they're nice to look at. Then exercise 4 on page 115, try A135, B1 and 3, do more if you want. Page 115 to 116 just revises your special angles. Page 117 has some extra mixed examples. And then exercise 5 on page 118. Try all of them if you want, but try A, C, D, G, I, J, K, M, and N. So what I'll be doing in the next day or so is just talking you through the answers for these exercises, just to help you. But please rather try the exercises first. Try them by yourself, mash it out, look at your examples in your textbook, rewatch the videos, and then go on to the memos. I don't want you to just jump to it and then you haven't tried it yourself. That doesn't help anyone. All it does is shows that I'm doing the thinking, not you. So please make sure that you think a little bit. All right, so, and then the next video that will come up is something called identities, which is just using all of this information that we have learned. And I'll recap it at the beginning of the video, and then we go on to something called general solution, which is about equations, and then that's it. The only other thing is trig functions, so there's not much to the trig section, but you have to practice as many types as you can. Right, good luck with that, grade 11s. You're more than welcome to ask me questions. I really don't mind if you ask me questions. You can ask them on the Google Classroom on the comments section, and I will get back to you. All right, good luck with it.